We begin our study of quadratic surfaces with an example, and the example is going to be based on the equation ax squared plus by squared plus zz squared equals d. First, let's note that a, b, and c, and d are all uppercase. We have the general equation of an ellipse, which is x squared over a squared plus y squared over b squared equals 1, or a hyperbola, which is very similar except one of these is positive while the other is negative, and we indicate that by plus minus x squared over a squared minus plus y squared over b squared. The plus minus plus are opposites, so if this is plus, this is minus. If this is minus, this is plus. And that's equal to 1, and that gives us our standard equation of an ellipse or a hyperbola. If it was x and z, then we'd have a hyperbola or an ellipse in the x and z plane. And if it was yz, we'd have an ellipse or a hyperbola in the yz plane. And we, at the beginning of the semester, did a good review, or you were assigned a good review of the graphing of ellipses and hyperbolas. You're going to need that if you're going to understand quadratic surfaces. So make sure you completely understand ellipses, hyperbolas, and parabolas, which I haven't mentioned here because it's a slightly different case and would take a little extra room. Okay, in any case, in the xy plane, what do we know? We know that z equals 0. If z is equal to 0, that means cz squared is equal to 0, which means that we're left. So the equation becomes ax squared plus by squared equals d. Now, this equation is in the form of an ellipse or a hyperbola, and it depends on whether a and b are both positive, both negative, or this one's negative, this one's positive, or this one's negative and this one's positive. Okay, the relative signs, the signs of x squared, the signs of a and b determine whether this is an ellipse or a hyperbola, and if it's a hyperbola, that indicates the direction in which the hyperbola opens. Now, that's assuming that d is a positive number. Another thing we'll observe is if d is a positive number, then both of these can't be negative because x squared and y squared are both positive. If both a and b are negative, then this side is negative. If d is positive, this side is positive, and that would correspond to no solution. And you do run into cases where there's no solution. Now, this is then of the form, and I'm going to have to come down to a Sharpie. I don't have room to write this with the big markers. You can verify that this is the form x squared over the quantity d divided by a plus y squared over the quantity d divided by b equals 1, to put this in the standard form. And if we look at these denominators, this is in the form x squared over a squared plus y squared over b squared equals 1 if a, little a, is taken to be the square root of whatever you get when you divide d by a, and b is the square root of d divided by b. Now, that's not a formula you're going to want to remember. You don't need to remember those symbols. All that we're doing here is we're indicating that to put this equation in standard form, we divide both sides by d to get 1, and then we bring the a down into the denominator using the rules of fractions, and we get this. And that will be of this form if a is the square root of d over a and b is the square root of d over b. And I've been a little sloppy here. I haven't accounted for the plus and minus or the minus and plus, but we'll see how that works out when we get into some actual numbers. Now, in the yz plane, what do we know? We know that x equals 0. So the equation becomes b y squared plus c z squared equals d, which is y squared over, again, you don't have to worry too much about the algebra here, but the algebra is going to come out so that what's under y squared is the square, and I didn't indicate that before. Let me come back here. No, that's all right. Okay. Square root of d over b plus z squared over the square root of d over c equals 1. Where again, you don't have to worry too much about the algebra of this. We're simply indicating this is going to be y squared over something plus z squared over something, and that something, those somethings can be indicated in terms of square roots of these ratios. Now, the point of this is, depending on the signs of a, b, c, and d, this could be a plus or minus here, plus or minus here. Again, we're going to see that when we put some numbers into these things, but the way the signs come out, if we could get an ellipse here and a hyperbola here, or we could get a hyperbola here and a hyperbola here. We also have the xz plane, where y equals 0, so that we get a x squared plus c z squared equals d, and so forth. And this is also going to be either a hyperbola or an ellipse, or possibly the sign of this side would be different than the sign of this side, in which case we would get nothing. Okay, so that's kind of an overview of the way we might look at an equation of this form. Now we're going to look at a more general form.